Now that we can find a determinant, we're going to use that determinant to find our inverse of our matrix. And here's the formula for the inverse. We take 1 over the determinant, that's going to be a scalar in front of our matrix. Then we're going to switch the top left and the bottom right. And then instead of switching, we're just going to negate the top right and the bottom left. So A and D switch places, B and C switch signs. They're not going to switch places, only their signs. Let's look at an example. Find the inverse of the matrix if it exists. So to figure out if it exists, first we need to find our determinant. So the determinant of P is 7 times -1 minus -5 times 2, which is -7, plus 10, which is 3. It's not 0, so our inverse exists. Now to find the inverse, we use this notation with a -1 at the top. That's telling us the inverse of matrix P. We do 1 over the determinant times A and D switch places, so now we have -1 in the top left and 7 in the bottom right. B and C switch signs, so -5 becomes 5, and 2 becomes -2. And now we're going to distribute that scalar to every single element, leaving us with -1/3, 5/3, -2/3, and 7/3. If we could simplify any of these fractions, we would, but these are already as simplified as they get. Let's look at matrix Q. Need to find the determinant first. So we have -8 times 9 minus -6 times 12. -8 times 9 is -72. Negative times a negative is a positive. And then 6 times 12 is also 72. So in this case, our determinant is 0. So here, our inverse does not exist. There is no inverse of this matrix. Let's look at a couple more. Finding the determinant first. 3 times -4 minus 7 times 1 is -12 minus 7, which is -19. We can find an inverse because our determinant was not 0. So we can put 1 over -19, or -1 over 19, times A and D switch places, B and C switch signs, and now we distribute our determinant. So negative times negative is a positive 4 over 19, positive 7 over 19, 1 over 19, and -3 over 19. That is the inverse of our original matrix A. Finally, determinant of B gives us 2 times 3 minus 1 times -4, which is 6 plus 4, which is 10. So we do have an inverse. Our inverse, we've got 1 over the determinant times 3, -1, 4, 2. And now we can distribute our scalar and simplify any fractions. 3 over 10, 1 over 10, 4 over 10 reduces to 2 over 5, 2 over 10 reduces to 1 over 5. And there's our inverse.